So now we're going to look at multiplying binomial radical expressions. So again, the principles don't change here. What we're doing now is we're simply incorporating the principle which we've already learned, that if I have something like x minus 4 and we square this, that's the same as x minus 4 times x minus 4. And when I expand this now, I have to remember that we have to multiply each term in the first brackets by each term in the second bracket. So I'm with x squared minus 4x plus 16, which is equal to x squared minus 8x plus 16. And we just have to bear in mind our radical rules. So root 3 minus 2 all squared is like saying root 3 minus 2 times root 3 minus 2. And now I'm going to expand this. So root 3 times root 3 is going to give me root 9 minus root 3 times negative 2 is going to give me minus 2 root 3. Minus 2 times root 3 is going to give me minus 2 root 3. And then minus 2 times minus 2 gives me plus 4. So I end up with, well, look at this. The square root of 9 is actually 3 minus 4 root 3 plus 4, which gives me, I'm going to simplify this. 4 plus 3 is 7 minus 4 root 3. A nice observation here is notice that when we multiply root 3 times root 3, I wrote root 9 and then I wrote 3 again, but you can think about square root times a square root. Since we're squaring the square root, it results in just whatever's underneath the radical sign. Let's do this next one. So we have 4 times 3, which is going to give me 12. 4 times root 28, which is going to give me minus 4 root 28. Root 7 times 3, which will give me plus 3 root 7. And then minus and a minus. Oh, plus root 7 times root 28. Let me just move this over a bit. Give us a little more room. There we go. Now we have a little more room. So we have pen. We have root 7 times root 28, which is root 7 times 28, all underneath the same radical. Now, what you might notice here is there's some numbers here that aren't very nice to work with. So one thing that might have been useful here is to check if 28 has any perfect squares in it, and then we might have been able to simplify this radical. The question asks you, well, does 28 have any perfect squares? And so we write down the number 28 here, and 28 factors 2, so that's going to give me 14. 2, so that's going to give me 7, and we know that 28 is the same as 4 times 7, so we can say 12 minus 4 times the root of 4 times 7 plus 3 root 7 minus root 7 times 4 times 7. So we had 12 minus 4, the square root of 4 is 2, times 2 root 7 plus 3 root 7 minus, well, now we have the square root of 4 is 2, so that's 2 times the square root of 7 times 7, which is 7 squared. And so we have 12 minus negative 4 times 2 is minus 8 root 7 plus 3 root 7 minus 2, and now the square root of 7 squared is 7. So we have 12, 8 minus 5 root 7, we've grouped these like terms in the middle, minus 14, 12 minus 14 is minus 2, so we get minus 2 minus 5 root 7. Now this is a little bit long and a little awkward, but notice that if I had taken 4 plus root 7 times 3 minus root 28, ideally what I would have wanted to do there is identify right away that 4 plus root 7 can't be simplified, but 3 times minus root 28 can be simplified to 2 times root 7. And this is actually going to make the math a little easier when I expand it. Let me pause it, do that, and then show you. So notice, had I simplified this root 28 into a mixed radical right at the start, my math is a little bit easier in some ways. But that isn't to say that you shouldn't be able to work it through in the other way. Okay, I'll leave the last one for you to try.